Hello everyone, in this video I will demonstrate how to perform paired sample t-test in SPSS. So let's have a look at the example of a very simple and basic exercise that on which we can run a paired sample t-test. So an experiment carried out to investigate the effect of stress on skill performance. Each participant carried out a choice reaction task under each of two conditions, stress and no stress. Performance was measured as the number of errors made in 100 trials. The experimenter is interested in whether stress affects performance. So it was hypothesized that participants will make more errors in the stress condition. And here is our data. So, firstly, we need to identify what is our independent and what is our dependent variable. So the independent variable is the condition, and we have levels, no stress and stress. And in this particular task, we have a within participants design, meaning that one participant, let's say participant 1, first did the tasks in no stress condition and then did task in a stress condition. Usually you would counterbalance to eliminate the order effect, and in here the data already cleaned up and put in order no stress. However, our dependent variable is number of errors they make in 100 trials. And number of errors are presented in here under the stress and no stress condition. So let's say participant 2, they produced 10 errors in non-stress condition and 17 errors in a stress condition. Another important part is to identify whether your hypothesis is directional or non-directional. In this case, we have a directional hypothesis because we predicted will make more errors in stress conditions. So it gives a precise direction where we expect our results to go. So when we enter our data in SPSS, it will look like this. So we have our participant, 10 participants, we have their no stress condition, and we have stress condition. So if we look at the variable view, we have participant, no stress on the scale, stress on the scale as well, both variables are numeric. So going back to the data view, before we run any test, we need to calculate means and standard deviation, so we need to have descriptive statistics. The reason for it, because you can interpret the results of the t-test only by looking at your means for two groups. It basically compares where the mean of one group is different from the mean of the other group. However, t-test is a test of mean differences, and it calculates descriptive statistics by default, so you don't need to perform a separate analysis to calculate the descriptive statistics for your data set. So, as usually, all tests are in Analyze menu. So we'll go to Analyze and Compare Means. And here we have the options of a t-test, and we know that our study is within participants' design, therefore we're using paired sample t-test to analyze it. So let's reset. What we have is first pair that needs to be analyzed. In SPSS you can analyze several pairs in the same time, but we only have one pair, no stress and stress condition. So we'll put our variables into the first pair variables. There we go, no stress and stress. There is nothing else you need to choose, so we just press OK. And here we go. This is the output, and we have paired sample statistic, which are means and standard deviation for our 10 participants. So we can see that in no stress, participants made 7.4 errors on average, where in stress condition they made 10.2 errors per average, which is going in a direction of the hypothesis. We also can see that the spread of scores, or the spread of errors, was relatively equal in both in stress and no stress condition. The next table you're interested is paired sample t-test, which actually shows you the statistics. In this case, we are interested in t-value, degrees of freedom, and whether it is significant or not. Importantly, the sign of the t-value depends which condition you subtracted from what. So in our case, in SPSS, we subtracted no stress from no stress, and because in stress condition they made more errors, our value is negative. If you entered the variable in a way that first variable was stress, the second variable was no stress, your t-value will be positive, but it will be the same t-value. So now we have 9 degrees of freedom. 9 degrees of freedom because we have 10 participants in total, and we use 9 degrees of freedom. We use the t-distribution based on 9 degrees of freedom to determine if our output is significant or not. And in here we see that our significance level for two-tailed test is 0.043, which is significant. However, you need to remember that our hypothesis was directional. In our hypothesis, we predicted that participants will make more errors in a stress condition. So we cannot use a two-tailed output to or report the significance for the two-tailed test for our exercise. So how you solve the problem is very easy. T-test always gives you a two-tailed test output, but what we do, we only work with the significance value, and basically we divide 0.043 by 2 to get a one-tailed test significance, and that will equal to 0.0215. So when you report it, you'll have to report that t with 9 degrees of freedom equals to minus 2.352, comma p is, you can either say less than 0.05, or you can say that p is equals to 0.0215, and in a bracket you would say for one-tailed test. You have to do a one-tailed test just because the hypothesis was directional. So, and the conclusion is that participants made the conclusion, the easiest way, always go to your hypothesis, don't reinvent the wheel. So our conclusion is that participants made more errors, or made significantly more errors in a stress condition. Okay, so that is it for the paired sample t-test.